This video caters to individuals interested in either learning Python through mathematical concepts or grasping mathematical concepts using Python programming. It's aimed at those who wish to discover how Python can significantly streamline the resolution of various mathematical problems through programming. Today's session will delve into demonstrating how Python can proficiently tackle a complex Olympiad math problem, where the computational approach isn't markedly different from solving a conventional school math problem in terms of intricacy. Moreover, we will explore how computers can aid mathematicians in discovering purely mathematical solutions by guiding mathematical reasoning down the correct path. To realize this objective, we will focus on a problem extracted from the Combinatorics section of the U.S. International Mathematical Olympiad Team training problems. Specifically, we will examine the seventh problem from the second part, which pertains to the more challenging problem subset. A mail carrier delivers mail to the 19 houses on the east side of Elm Street. The carrier notes that no two adjacent houses ever get mail on the same day, but that there are never more than 2 houses in a row that get no mail on the same day. How many different patterns of mail delivery are possible? Let's attempt to create a visual representation of a potential mail delivery arrangement. For instance, let's denote a scenario where the first house doesn't receive mail as 0. In contrast, the second house receives mail, and we'll represent this as a 1. Subsequently, if the third house also doesn't receive mail, we'll denote it as 0. This pattern of representation will continue accordingly. We have the option to view the task's animation in a single line within the terminal. Alternatively, we can expand all rows to gain a comprehensive view of the initial solution. As is evident, the system engages in a process of trial and error, seeking viable options. While this simulation is basic, it effectively illuminates the essence of numerous simulations. Let's now shift our attention to the Python code. The solution to the problem is located within the 5th chapter of the Colab notebook document. The initial solution comprises 2 functions: generate random solution and experiment. The experiment function, which will also be employed in the subsequent solution, takes 2 parameters. The first parameter signifies the number of houses on the street, and the second denotes the frequency of attempts to deduce a suitable option. Within the function, a container of the set type is established to hold the results. The utilization of the set type is chosen due to its ability to store only distinct objects. If an identical object is added multiple times, Python ensures that only one unique instance is retained. Subsequently, within the experiment function, a for loop is structured. During each iteration, the generate random solution function is invoked. This function furnishes a randomized yet viable mail reception outcome. How does the function generate random solution operate? This function generates random ones and zeros in succession until it constructs a sequence of ones and zeros that represents the distribution of mail. With each random bit generated, the function assesses whether the problem's stipulation is adhered to. That a 1 must be succeeded by a 0, and 2 consecutive zeros must be followed by a 1. Upon executing the code, we arrive at the accurate solution: 351 distinct mail distribution patterns that satisfy the task's condition. It's evident that this approach provides a relatively straightforward solution. Moving forward, let's explore the route to an analytical solution. To embark on this journey, we invoke the experiment function, not just for a group of 19 houses, but also for various other groups where the number of houses ranges from 1 to 30. Upon running the code, we obtain solutions for all the different house groupings. Our next step involves discerning if any patterns emerge within the sequence of numbers acquired. It becomes apparent that this sequence follows a recursive pattern. Each number is the sum of two preceding numbers, with one being positioned 2 steps back and the other 3 steps back. While this sequence may not be as renowned as the Fibonacci sequence, it elegantly offers a solution to our problem. Consequently, we are led to a hypothesis that we can endeavor to substantiate through mathematical means. The mathematical solution unfolds as follows. We initiate by generating arrangements for 2 house scenarios. Subsequently, we move on to generating arrangements for 3 house scenarios. Following this, we repeat the process for 4 house scenarios. Finally, we extend the approach to encompass 5 house scenarios. Now, we classify the 5 house arrangements into 2 distinct groups. The first group involves arrangements with 1 followed by 2 0 digits from the leftmost position, while the second group comprises arrangements with 1 0 and 1 digit, commencing from the leftmost position. Removing 1 0 and the consecutive 0 digits from the first group yields the same arrangements as those for the 2 house scenario. Likewise, eliminating the initial unit and the subsequent 0 from the second group leads to the 3 house scenarios arrangements. In this manner, we substantiate our hypothesis and systematically solve the problem through mathematical deduction. For a more comprehensive understanding of the mathematical solution, you can refer to the link I've provided, which directs you to the solution's detailed explanation. I trust you found value in this video, showcasing the feasibility of solving math Olympiad problems utilizing the Python programming language.